The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Good morning, good afternoon, good evening. I'm Rob Meyer. I'm going to be your host today. We're going to start in just a second, but first I wanted to make sure to conduct a bit of normal housekeeping. Raise your hand, not physically, but on your browser. You should be able to see, I think, under the questions or under where you're listed, you should be able to click on a hand and let me know you can hear me. Okay, we see some hands going up. If you can't, feel free to type into the chat or the questions window, and I will get back to you while we're doing the session just to make sure that you're all set. But looks like we're all set. So during this webinar, you're going to be on mute, so please do use the questions. Don't talk to your machine. Feel free to type. I'll answer during, or I'll save some of your hardest questions if you have some questions for the end for Dennis. At the end of the webinar is when we're going to take as many of the hard questions as possible. But first, let me give you an introduction to today's speaker. If you've attended some of these webinars before, you know who Dennis is. Dennis Magda is the PMC chair for the Apache Ignite project. He is also, he runs inbound product management at GridGain. So today he's going to be talking about Kubernetes, Kubernetes in general, and also using Kubernetes with GridGain, and in particular here with Apache Ignite. One of the things that we found while we were using Apache Ignite was that there were some general lessons to be learned about Kubernetes, and that is part of what Dennis is going to go through today around how do you deploy and provision an in-memory data grid or an in-memory database. How do you set up the persistence in Kubernetes? How do you do auto discovery? But also just in general, lessons to be learned about Kubernetes. So with that, I'm going to turn it over to Dennis and get started. Take it away, Dennis.
Thanks, Rob. Thanks for the introduction and for the initial coverage. And hello, everyone. Thanks for stopping by our webinar. Hope that you will enjoy it and you will find a lot of useful information for your specific needs. And as Rob said, today we are going to just walk through the guidelines on how you technically deploy a distributed database or in-memory computing platform with Kubernetes. As you already guessed, we are going to use Apache Ignite as an example of such a storage technology, but overall, all the details that we are going to cover can be expanded and used for another product of your choice. So a lot of the things that we are going to mention can be generalized. So keep this in mind, but be ready that all the examples and all the materials will be covered in relation to Ignite as a distributed database and in-memory computing platform. So the agenda is pretty simple for today. I assume that all of you who joined us today are aware of Kubernetes, so we are going to skip a basic introduction of that provisioning system. At the same time, we are not going to just to do the same for Ignite, because the talk assumes that you already know something about Ignite and Kubernetes, and our aim would be, just to see how Ignite is deployed there. And then all those principles, as I said, can be expanded to another distributed databases and in-memory computing platforms. First, we are going to see and check distributed databases specificities, deployment specificities within Kubernetes. Then they're depending on whether you're going to deploy a stateful or stateless storage in Kubernetes. There are different techniques how to do the first or the second. So that's why we are going to review memory-only deployments separately. Those deployments apply for Ignite and towards other in-memory databases or in-memory data grids. And the other ones, you need persistence. You need to think of stateful deployments that are also possible to do, as you know, with Kubernetes. And finally, once you have your distributed database deployed in Kubernetes, we want to know how to monitor it and how to manage it. There is a variety of different tools available for us. Some of them provided by Kubernetes, some of them are provided by a database, and we are going just to quickly brief what's available for us. And finally, the theoretical part will be, it will take us 20 minutes probably to do the first 4 points of the agenda, and then we are going to switch to our demo. So I'm going to use Microsoft Azure to demonstrate how to deploy Ignite with persistence enabled there, how to connect to Ignite from management and monitoring tools, and how to connect to Ignite from a local application running on my laptop. So we are going to review all the major things you need to know if you're going to deploy Ignite in your Kubernetes environment and code an application for it. And finally, we'll have some time for your questions and answers. So keep them in mind, and as Rob said, write them down in that chat window. So let's move on and start with the deployment specificities with Kubernetes. So because initially, as you know, Kubernetes was designed for stateless applications, right? So that you have different pods in Kubernetes, and a pod can be shut down and then it can be restarted. And it was assumed initially that actually you don't need to preserve the state because the pods can be deployed whenever it's needed and depending on the current state of affairs of your Kubernetes deployment. But then, as Kubernetes started ramping up, there appear different use cases where the persistence was required and where stateful applications needed to be deployed within Kubernetes. And after that, so technically Kubernetes provided capabilities required for that. However, when we talk about distributed databases deployment in Kubernetes, we need to consider some of the specificities. The first one is that a distributed database in Kubernetes is a set of two or more Kubernetes pods, which means that you need to find a way how all these pods discover each other within your Kubernetes environment, and so that they can interconnect and form a single cluster for your distributed database. So here is usually what are the difficulties with that? First, in Kubernetes, usually all the IPs for your pods are assigned dynamically, only after your pods are started, which means that your distributed database need to have some special component that is able to pick an assigned IP address and use it and find out IP addresses of existing nodes in your cluster, and only after that to connect every node with each other. So it all means that we need to have some sort of auto discovery of our database pods within our Kubernetes deployment. Also, we need to know technically if you deploy, let's say, a relational database such as MySQL or PostgreSQL or within Kubernetes, it doesn't really matter whether your application will be deployed, your application that is going to work with that database, whether that application is going to be deployed in or outside of Kubernetes. Because if it's deployed outside, you can just create a Kubernetes server, such as a load balancer or another one, and an IP address of your database will be exposed to your applications. But with a distributed database, it's much challenging. Because as we know, a distributed database, again, is a set of Kubernetes pods. Every pod has its own unique IP address. And here it's not clear how our application that is deployed outside of Kubernetes is going to connect to our Kubernetes machine. So here there are different scenarios. Again, we can use Kubernetes services in the load balancer mode, and we are going to see how to do that with Ignite deployments. Or you can expose IP addresses of a specific pod that is a part of your distributed database cluster, and you can use some other protocols such as the REST protocol or protocols for SQL connectivity, and etc., etc. And the final thing is to decide whether you're going to deploy a stateless or stateful database. For the stateful database deployment, you need to configure disks or persistence within the Kubernetes, and it's us some extra steps. For the stateless, the things are much easier, but you need to preload your data to your in-memory databases somehow, and you need to be sure that the data is reloaded if your whole cluster is restarted. That applies to the stateless deployments. So now let's review the first 2 points. So database, how actually a distributed database such as Ignite can be deployed within Kubernetes if we don't know IP addresses in advance of our nodes. So the idea is pretty simple. So we know that in Kubernetes we have services, and you can configure a service in such a way that it will track all the IP addresses of the pods you need. For instance, in Ignite, we tapped into that capability. All the Ignite pods that are started within Kubernetes have a special label, such as Ignite. And then we start a special Ignite service, Kubernetes service, that keeps an eye on all the Ignite pods. And as a result, that service knows all the IP addresses of all the pods that are alive. And this is the first part of bringing in the nodes auto discovery to Kubernetes. The second part is that we need to use a dedicated IP finder for our cluster nodes within Kubernetes. And that IP finder's implementation is pretty straightforward. So as it's shown on this picture, once Kubernetes starts another Ignite pod, this pod will connect to our Kubernetes service using the Kubernetes IP finder. The IP finder will retrieve all the IP addresses of existing cluster machines that are already running in our environment. And after that, the IP finder will pick a random IP of an existing cluster node and will connect to it. This way, the node will join the cluster of existing machines. So it's really pretty straightforward. And the IP finder is pretty simple. So this is actually how the pods auto discovery works for Ignite within Kubernetes. But this logic, to be honest, applies to the rest of distributed databases. The main point here is that a distributed database needs to have a special networking component that can grab all the existing IP addresses of database nodes and then use those addresses to connect to the existing cluster. So it's pretty straightforward. And that's actually all you need to do on the database size to make sure it can be deployed in Kubernetes. So, and if to elaborate on this service, so the service configuration is just can fit on this single slide. This is how the service configuration looks like for Ignite. I just copied and pasted it from the Ignite service YAML file. So here is, if you take a look at this configuration, what we are doing, we're defining this. First of all, we are saying that the service, and as it's highlighted in red, the service is going to keep an eye on the Ignite paths only, which means that this service will track all the IPs of those nodes that are needed for us, and that information will be utilized, as we said, during the time a node joins the cluster. And also, if you want to reuse the same service for the connectivity purpose, for the applications that are deployed outside of Kubernetes. The applications that are deployed inside of Kubernetes can connect to our cluster directly. They will be deployed as pods, and they will be able to connect to any Ignite cluster node running in Kubernetes. But what to do with applications that are not deployed in Kubernetes? We can define a load balancer service, the same service we use for the auto discovery, and open the port numbers that we are planning to use. For instance, here is we are opening the port number that will be used for our REST protocol, for our SQL interactions, for meaning that for JDBC and ODBC drivers, there is a port number for Ignite Thin clients, which is a lightweight client that can be used to connect from any programming language you like. And that's all. And then what we need to do is just to start the service using this trivial Kubernetes command, and you will have it running. After that, you are free, you are ready to deploy Ignite pods. And finally, the other thing, it's about IP Finder, right? We talked about that IP Finder. And that's the part that has to be added to your Ignite nodes configuration. Here, as you see, that we activate special TCP discovery Kubernetes IP Finder. And we are saying that, and this IP Finder already knows that by default, the name of the service that tracks all the IPs is Ignite. And also here, we assume that all the that Ignite deployment is located in the Ignite namespace. So we also just did this, but we skip this for the sake of this presentation. So that's all. And it means that once you start your node with this configuration, the node will automatically locate the service within Kubernetes, will grab all the IP addresses, and will use one of their IP addresses to connect to the existing Ignite cluster. This is how actually you will build out your cluster, how you will scale it out within Kubernetes. That's all what you need to do from the software engineering standpoint. And now, now we have all the infrastructure needed, right? We have the service, we have IP Finder, and now we are ready to deploy Ignite as a distributed database there. And now let's start with the simplest scenario where we want to use Ignite as a memory database or a memory data grid that doesn't have any, let's say, persistence enabled. So it's also a valid use case for some of the deployments. Before we dive into this, let me remind you what are their Ignite memory usage options. The first one is Ignite as in memory, right? Here is we are going to use only in memory layer, in memory storage, all the data and indexes will be allocated there. And actually that mode is used to achieve the maximum performance possible because the data will never be written to disk. Here is the similar, it's similar, this mode might be similar to many Redis or Memcache deployments or other memory database deployments where you just need to store your data set in memory and don't worry about the disk layer at all. Another option, and we are going to review how to deploy these Ignite in this mode shortly. The other two are, the second one is used when you want to accelerate your existing database deployment, such as a relational database or NoSQL. It applies for in-memory data grid scenarios. We are going to skip it for today, but technically what you want to do in Kubernetes, if that's your case, you need to deploy, let's say, your Oracle database as a part or as a service separately, and then you need just to deploy Ignite separately and stick those databases together. The last two things are what we are going to review after the in-memory mode, and we are going to use Kubernetes stateful set to activate Ignite persistence, because with Ignite persistence, now we are going to have unlimited data scale beyond RAM capacity. So all the data in our demo is going to be stored on disk across several pods deployed in Kubernetes, and also we are going to cache the same amount of data in Kubernetes. But now let's do this step by step and look into the in-memory deployment only. So with the in-memory deployment thing is really it's really trivial. So here is we don't need to use any exotic configurations or cumbersome configurations. We can just tap into Kubernetes deployment entity as it's shown on this slide. So we just defining basic parameters such as name and number of initial replicas, or which means that how many nodes, Ignite nodes will be started by default with Kubernetes. And then we are saying what is essential here that we just need to pass a configuration parameter, which is highlighted in red. And that's all. And then you just you pick Ignite version you'd like. You can enable another additional libraries for Ignite, and that's it. we use this simple Kubernetes command to deploy our Ignite cluster, and we will get it started. And this is how you deploy Ignite in the in-memory only mode. And then, if just to go back to the previous slides, right, we already have our service deployed after that, before that, right? And the service knows about these parts, and you will be able to connect to your Ignite cluster from the applications that are deployed outside, if you use IPs and port numbers exposed by the service, or you can deploy your applications within the same Kubernetes cluster, within the same namespace, and your applications can interact with Ignite directly without the service as a gateway. Now let's have a look. Let's go to the next part, which is our stateful deployment. Now we want our distributed database to have persistence enabled. Why do we need persistence? Several use cases. First, it might happen that the whole cluster goes down, probably because your data center was shut down by some reason, and you don't want to lose your data set, and you don't want to preload it to another location. And the second one, you don't want to store all the data in memory. You don't want to keep 100% of data in memory. And the persistence is required for in Ignite for these scenarios. So with the stateful deployments, usually the stateful set in Kubernetes, again, is used to persist data to disk, right? It's pretty obvious. And also it's designed in such a way that you can restart your parts in some order. This is actually relevant for some of the disk-based databases that require you to restart the parts in a special way. This parameter is irrelevant for Ignite, because in Ignite it doesn't matter what would be the order of your Ignite parts restarts if you need to do that. So for Ignite, the stateful set is only needed, to allocate storages, disks, and to put datasets, indexes, write-ahead logs there. Today, as it's shown on this slide, we are going to use a pretty simple and the simplest stateful set configuration possible. So here is we have again simple parameters, basic parameters such as service name that is going to monitor the stateful set, and we have skipped some of their things such as port numbers and etc. What's our point of interest here is the volume claims. So here is we just want to deploy, we want to ask the environment to provide a special disk where we can store all our data. We are going to use it as an Ignite storage, and we are claiming, let's say, just 1 GB RAM, and that will be that request will be executed for every Ignite part that is going to be deployed there. So in reality, what also we suggest you to do when you go in production is to configure different storage classes for different disk needs in Ignite. For instance, you know that if you when you enable persistence in Ignite, or you use another probably strongly consistent database, or even NoSQL database as Cassandra, you're going to write data to disk, and you're going to update transaction logs or write-ahead logs or special write-append files. It's better to separate the disk for those types of data, so that the write-ahead log file is stored in one disk storage, and it's updated separately from your main storage that keeps data in the indexes. Also, if you're going to do snapshots and backups of your storage, it's also recommended probably to allocate a different storage for them. So the whole goal here is that to meet possible possible fighting for the resources of your disks, so that every type of workload has its own disk, such as data indexes one disk and write-ahead logs are stored on on another disk. Next, that's all actually about stateful set. Once you deploy your Ignite stateful set, you will have the persistence enabled, and you also need to enable Ignite persistence in Ignite configuration, which is just several lines command. However, another thing that is important about Ignite persistence is that you need to activate your cluster manually on the first start. The idea here is there is a reason for that in Ignite, because Ignite wants you to tell that now all the nodes with persistence enabled are up and running, and you are ready to make your cluster available for the workloads of your applications. And also it's needed especially on the restart when, let's say, part of the nodes is already up and running, but the other part is down still, and we don't activate the cluster until all the nodes are interconnected. But anyway, so for the very first start, you need to activate your cluster manually. So here is on the screen, it's shown 3 commands that you need to use to do that if you are deployed in Kubernetes. So first you need to connect to one of the Ignite pods. Here is we are connecting to Ignite-0. Then we are going to a bin folder of Ignite that contains all the required scripts, and we execute Ctrl+H script to activate our cluster. After that, your applications are good to interact with your cluster. However, you don't need to repeat the separation over and over again if your topology size doesn't change. Upon restart, the cluster will be activated once all the nodes of your baseline topology are up and running. So the baseline topology in Ignite is a pretty simple concept. It means that it defines a set of nodes that are going to store data in Ignite persistence. And you can, for sure, you can change this baseline topology over the time. You can expand it, or you can shrink it. You can scale it in or scale out. But if your topology stays the same, you don't need to do any manual activations on the restart. This is something that worth keeping in mind. So that's all about deployment specificities. It's really pretty simple, and now you will see how in a few minutes you will see how it works in Microsoft Azure Kubernetes deployments. However, another important piece is management and monitoring of our clusters deployed in Kubernetes. And here I would define two things. The first one is that first we need to monitor Kubernetes environment in general. And here we can use a variety of different tools available in the market. So probably the one which is the most standard one or the most well-known is Kubernetes dashboard that is supported by any Kubernetes environment, and we are going to use it today. But in general, there are other tools, and you're free to use them. So the goal here is that in addition to the command line interface, sometimes we'd like to observe our Kubernetes deployments using some nice UI that simplifies the things for us. And also, as for the Ignite cluster deployments, we can leverage from Ignite Web Console, which can be used, to manage and monitor the state of our cluster and to run some queries, to do snapshots if you use persistence, and etc., etc. And here is when it comes to the question of Ignite Web Console deployment in Kubernetes. So here is probably my suggestion would be, to deploy the console within the cluster, because the console goes with a special application, web agent, which is a bridge between your Ignite cluster and your web application, your web console. Or if you, for instance, have your web application, your web interface of the console deployed outside of Kubernetes, then you just need to take that small piece, which is web agent, and deploy it in Kubernetes. So that web agent can access all the cluster nodes it like within the Kubernetes network, but also that web agent can access your web interface deployed somewhere else. And actually, we are going to use this approach today. So I'm going to use console GridGain.com, which is deployed on probably in Google, somewhere in Google Cloud. But my Kubernetes will be deployed in Microsoft Azure, and my web agent, my bridge, will be deployed in Kubernetes on Azure as well. And it's going to connect to be a bridge between my web console interface and my Ignite cluster. So it's that's all. That's actually all the steps you need to keep in mind if you going to deploy Ignite in Kubernetes. As you see, it's really straightforward, and then it just comes to your requirements, to the tuning, and for your business needs. So here is, you just need to decide what are the disks you'd like to use, what type of nodes or machines you'd like to allocate for your Ignite cluster, and it's up to you. But the general thing is that you just need to use several major components. You need to use stateful sets. You need to use Ignite service to make sure that your Ignite cluster is up and running in Kubernetes. And now let's have a look at our demo. So as I said, we are going to demonstrate our deployment in Microsoft Azure. And I did the homework, and before this presentation earlier today, I deployed my cluster in Microsoft Azure. I hope you see the screen. So that's Microsoft Azure portal. We have everything we need here. I allocated some of the resources. I have 4 nodes, and also in addition to that, I decided that instead of Microsoft monitoring capabilities and screens, I'm going to use Kubernetes dashboard. So that's that dashboard that goes with every Kubernetes release. Yeah, looks like I need to restart it because sometimes it breaks in my network, but it's not a big deal. Let's do this. So there is a special command how to restart this that helps us to restart this dashboard. Okay, now I want to use this browser. Okay, we have connected. So now I'm connected from my local laptop to my Kubernetes service. Here is I have, if I'm not mistaken, yes, I have 4 nodes allocated for my Ignite needs. Then I already have several persistent volumes allocated for my Ignite pods that have persistence enabled. The storage class was chosen by Kubernetes, so I didn't provide any specific details. But as I said, I encourage you, to predefine different storage classes for your data and indexes, for your data, for your actual database, and for your write-ahead local transactional files. It's also a pretty simple operation to do. And also, as for the paths, I've already have 2 Ignite cluster nodes deployed in my Kubernetes environment. And also there is that web agent application. That web agent actually connects my Kubernetes, my Ignite cluster within Kubernetes, to the console web interface that is deployed on console.gridgain.com. And all this allows me to monitor my cluster from this deployment. Let's see. Yeah, we could connect. And this monitoring tool shows me, okay, so I have 2 Ignite nodes, which is true, which doesn't contradict to the information of Kubernetes dashboard. And we have persistence enabled. Also, the persistence, the same two nodes will persist data to disk, but we don't have any data, we don't have any caches, no, we don't have any tables. And now it's good time, an opportunity for us to connect to our cluster from the application side. So, and as for the application side, just decided, that I would take GDBC driver, connect using SQL line tool, preload some database into my Kubernetes environment, and run some queries. So to do that, right? So we discussed if you're going to connect to the cluster from the applications deployed outside of Kubernetes, we need to use Ignite service. So where is my service? Ignite service that is used for the nodes auto discovery also can be used as a load balancer. Here is the external endpoints. This one is for the REST protocol. This one is for the SQL queries for our GDBC, ODBC drivers, and this one is for the thin clients. I'm going to use this endpoint to connect from my laptop. And actually, I've already have this separation here. You can see it right there. So I'm going to use SQL line script. And this script goes with every Apache Ignite release. It's located in the bin folder. So I just want to let me copy and paste this command. I'm just going to connect to my cluster. Okay, I've connected. Let me see how many tables we have there. We have nothing deployed. And the second part is, now let's preload some sample database. And Ignite, also every Ignite release now goes with a sample database, which is a so-called wall database okay, so it's not here. Let me try to find it. Actually, that database stores all their cities and countries in the world and provides various details such as population, languages, and etc., etc. And it's widely used by different other databases for the sake of demonstrations. So where is my database? So it should be located somewhere. Let me see, where am I? So the database, so we want to run it. So examples, so something config. So looks like I lost my script file. Give me a second. We can quickly look it up. So it should be somewhere. Downloads. I have Apache Ignite 2.5. So it's in examples. Okay, so probably I've connected. What was my Ignite version? Let me see. Okay, looks like I'm connecting using a wrong Ignite version. That's why I just don't have the script in there. So, but what we can do, I just can go to, it doesn't matter. I don't want to reconnect with another version. What I can do, I just can copy and paste the same script. I know. I would better quit and reconnect using Ignite version 2.5. So we are connecting within the same connection string. And now I hope I could preload my database. Okay, wonderful. So I'm preloading my database. So I just created several tables and then sorting data. And so now, once the preloading is done, we can see that we have all the tables deployed there. And if you go back to our monitoring screen, here is I have city, country, language. I can run different queries from here or from my console connection. So for instance, here I have a query with joins, which actually returns me the most populated cities in countries such as China, Russia, and United States. Shanghai goes first, the New York takes the third place. That's all. That's actually what I do. That's how it was easy for me to connect, from my local laptop to my Kubernetes cluster deployed in Microsoft Azure. That's all I need to know. I just connection through that Ignite service. And also, I for sure can run on all those queries from, let's say, from my web console. For instance, here is I can run query like that returns the most populated countries in the world. Again, this query is executed over the Kubernetes database. Here is I have the same top 3 cities query, or I can run individual queries for getting data for specific city, and etc. etc. It's all pretty straightforward. Also, if you want to do snapshots, here is, I'm using Ignite. So if you want to do snapshots, then we need to switch to GridGain Ultimate Edition. So we are not going, it's not a point of our presentation for today, but if you need it, you can do it on your own later. So that's all. And final thing, so about scalability, right? If you want to scale your Ignite cluster, you can use handy Kubernetes commands. For instance, let me use this command. Where is my Kubernetes nodes? Yes, that's my connection to the Kubernetes. So I have kubectl get pods. I have 2 pods deployed, and I now want to scale my cluster to 4 pods, which will mean that I will have 4 nodes Ignite cluster. I'm doing it in here, and now it will take some time for Microsoft Azure to get those pods started, but that's actually all. And Kubernetes, you can use Kubernetes to manage, their scalability question of your Ignite cluster. You can automate it. You can, depending on your workloads, you can prepare scripts that would shut down or start extra Ignite nodes with Kubernetes whenever you need it. So it's pretty simple. So that's the whole demo. And so if you want to repeat it, you need to, you actually can go to our Apache Ignite README documentation that is being refined right now. So we prepared Kubernetes section, and going forward, here is you can find detailed instruction on how to deploy Ignite with stateful set or stateless in the stateless mode in Kubernetes, step-by-step guide. And later on, you will find details for other major cloud environments such as Amazon AWS, or Google Compute Engine, or OpenShift. So stay tuned. And finally, before we go to the questions and answers section, let me tell you the following, that we are hiring. So we are looking for contributors and for our Apache Ignite community. So being an Apache Ignite community member, you can learn a lot about distributed computations and distributed computing in general. Or also, if you want to strengthen or gain new skills in databases development or SQL engine and etc., it's also a good place to be at. So join us. We are and today and nowadays it's probably one of the right moments to do, because Ignite was announced as one of the fastest growing projects in Apache Software Foundation. So for instance, according to the latest metrics, Ignite is the most active project ranked by the developer list Also, we took the second place at the most active user list. So it means that this is, you can see how much interest Ignite drives within developers and engineering community. And also, as for the commits, we are close to Camel, Hadoop, so we are just fourth. And here is, I would just point out that there are more than 300 projects in Apache Software Foundation, and Ignite is getting momentum. So join us, be a part of this moment, and gain new skills that you can acquire with being an Apache Ignite contributor or committer. So, and finally, your questions and answers. And last thing is that if you need more details, want to learn more about Ignite or GridGain, here is you can find the references to our websites, and also follow us on Twitter. So Ignite, GridGain, and my personal account, where you can find interesting tweets about in-memory computing, about distributed databases, not only about Ignite, but about their segment in general. So thanks for that, and we'll be happy to answer on your questions.
All right, well, thank you. I did want to point out that in October, we are also doing an in-memory computing summit in San Francisco up in the Hyatt. So if you are interested in coming, please reach out and let us know as well. But now I get to ask the questions and you get to deliver the answers, Dennis. So let me start. I think these set of questions are really around how do you set up Kubernetes with the resources around it. The first question was around, I'm going to reorder the questions a little bit. There was one question around setting up the JVM. Are there particular settings, particular configuration settings for the JVM that should be used, and where would they find that information? Or is it pretty much standard? You don't have to worry about how you're configuring the JVM.
It's pretty much standard. It just depends on what types of machines you're going to use for your Kubernetes deployment. But the suggestions are all the same as for the on-premise deployment or on pure and cloud deployment. So it depends on your environment. We just have those, general recommendations on how to set up and configure your JVM, and you can find them on Apache Ignite README documentation portal. And for the Kubernetes deployment, it's all the same. Just depends on what would be the machines.
So they should just look at the standard configuration options inside the doc for Ignite, and then same for Kubernetes. They don't really conflict. It's pretty standard stuff.
Right.
Okay. For the file system for storage, you'd mentioned using different spindles, for example, for different writes. Like your write-ahead log should be on a different disk, physical disk from your database. But what are other recommendations? Someone asked about Gluster FS, using some distributed storage. How do you set up in general the storage, the disk, the RAM, and SSD? How do you grab that for a pod and make sure it's dedicated or not dedicated for each pod that you're using?
So here is this recommendation on keeping write-ahead logs separately from the database files is also generic, and you can find this and similar recommendation within our documentation. There are special optimization suggestions for Ignite persistence enabled. And answering on the second question, here is you need to configure different storage classes for your Kubernetes deployments. For instance, the first one would be for your database files, the other which might be slower and cheaper for your write-ahead log files. And then in your stateful set configuration, basically you need to claim both storage files. That's what you do. And finally, you need to do a simple configuration change in your Ignite Spring XML configuration, saying that, let's say, my write-ahead log files will be stored in this mount point, and this mount point is located on one disk, and the database files will be stored in another mount point. So we are planning what we are doing right now. Our Kubernetes and Ignite experts are preparing detailed instruction with samples on how to do that, so that you don't need to do manual research. But in general, it sounds the way like I'm describing. You just need to allocate different storage files and claim them both, and then in Ignite configuration, just you need to say that, okay, my write-ahead log files have to be located on this mount point, and the database files on a different one.
Okay, so I guess for Gluster specifically, they should probably just post on the Ignite user list to see who else has been using it.
Yeah, so I know that these questions came up several times, and we know that there is a way. It's like it works. It's just a lack of documentation. I know that some of the Ignite and Kubernetes experts have been working on this. They just need to finish it up. And right now, like today, we demonstrated the simplest use case possible. But usually, you separate write-ahead log files from your database files, to achieve better performance.
Yeah, and I guess you're going to do the same thing with Kubernetes. You're going to assume you're kind of going to dedicate certain boxes to certain workloads, even if you're using Kubernetes on them, just because of the throughput you might need for the underlying disk. And the same probably goes with RAM, that you may be grabbing RAM, but you have to assume that you know everything that's running on Kubernetes and other parts of that box to make sure you have enough RAM to actually fulfill everything. Yeah. Okay. Next question. Suppose, and this is more about the first time start and the restart. Do you have to, first question around that is, do you have to do a manual restart for each pod the first time? It's just one command across all the pods, right? For GridGain to start it up the first time?
Yes, so what I did today, you just connect to one of the pods, and that pod will activate the whole cluster.
Okay.
Or even to make things simpler, what I did, to be honest, I didn't use that command. I just know that you can do this from your terminal window. What I did instead is that I just went to my web console, and I just turned on this button. So before my cluster was deactivated, and then I just switched it on. This is what I did. So, and it does the same thing. Your web console connects to one of their Ignite pods and executes that similar command to activate the cluster.
Okay, so if I have multiple pods, you're saying I do a manual restart on one pod and I have all the config information in there, it's going to automatically restart the other pods the first time.
So if you talk about, so if now that's about
the first
manual activation, the first one. Yes, if you do a restart, technically you don't need to do anything manually, because once Ignite sees that all the pods are up and running,
right,
that were part of your baseline topology, it will activate the cluster automatically.
Yep, and if you had baseline topology with multiple pods, your first manual start, any pod can start everybody else. So
it means that the cluster, yes. So, but here is, for instance, we have, and you remember that before, right after the end of the demo,
right,
we scaled our Ignite cluster.
Right.
Yes. Now we can see that. Let me check. Now we have 4 Ignite pods up and running. So we scaled the cluster, and here is we see that. But our baseline topology consists of 2 Ignite pods.
Yeah.
If you want to expand your baseline topology, that's required if you use Ignite persistence. You need to do this manually. So I just need to turn this on, and in several seconds. My I will have more capacity for my Ignite cluster. Then, if you shut down, restart your whole cluster, once all these 4 nodes are up and running, your cluster will be activated automatically. You don't need to do any manual interventions.
Okay, so now you're rebalancing across Kubernetes. You're rebalancing across the four pods now.
Mm-hmm.
Yeah. Okay. Another question was with Web Console. Suppose I'm not using the online version. I'm not using GridGain. I'm not using the online version, but there's the Ignite Web Console. Do you install that on a separate pod, or do you install it on one of the same pods? What do you do generally with Web Console within Kubernetes?
So I would install it. I don't know. So it makes sense to install it on a different pod. And usually this is what I did. But I don't know, in my scenario, I guess that my web agent is deployed on one of the nodes available. Here is when I talk about nodes, I assume Kubernetes nodes, which are machines. But if you have, it depends on how
load. It's not putting a significant load on the resources, right?
Yeah, I think so. Yeah, I think so. So even if you deploy it on the same pod with one of your cluster, with one of your Ignite pod, it shouldn't, bring down the performance of that machine in general. So.
Okay. I should remind everyone, if you have particular questions like around performance, and you are doing it and you're hitting some issues, submit on the Ignite user list or on Stack Overflow, and people are pretty good about helping you figure it out. I'm seeing one performance question here. I just saw something very similar answered the other day. So, and it could be an indexing question. So go ask online, and depending on what you're trying to do, you'll get a very specific answer. Another question was, monitoring is not part of the open source web console.
Yeah, it's not.
It's not, right? So it is part of GridGain, but it's part of the online hosted console.
Mm-hmm. Right. It's like I'm using this one, console.gridgain.com, and I don't. Right. And it's available for me for free, everything. Like I just registered there and I connect to my cluster and it's free of charge.
Right. So the short of it is the online web hosted GridGain console, which is free, correct, can monitor a Kubernetes cluster, but deploying web console within Kubernetes on a pod won't have all these features.
No. Yeah.
Okay.
It won't.
I think those are, I'm looking through, I think those were all the questions we had. So, Dennis, I want to thank you for answering all these questions. If anybody has any other questions, the easiest thing to do is to submit on the user lists and get other people to answer. People are pretty responsive. But feel free to do that. Feel free to contact us about the In-Memory Computing Summit. And with that, Dennis, I want to thank you for going through Kubernetes. I know I learned a couple things. So hopefully we see you in the next round. I think we're going to do another Kubernetes best practices webinar, I think. Is that right, Dennis?
Yeah, we plan to demonstrate how to do multi-cluster data center deployments.
That's right. So for geolocational and other kinds of multi-data center deployments, we're going to go through some advanced best practices. We're going to do more about streaming. We're going to do more about advanced, I think, multi-cluster deployments. I think Lucas is going to spend some time telling us what he's done with different customers and how they've deployed. So lots of stuff coming up leading up to the October In-Memory Computing Summit. So hopefully you'll join us again for another webinar. But in the meantime, we'll see you on the Ignite user list or Stack Overflow or somewhere else in a meetup. So thank you all for attending and looking forward to chatting with you again soon.
Thanks, everyone. See you.